everybody. You know me already from the last time. This is why I accidentally skipped the naming part here. I'm Alexandru Egner. I'm coming on behalf of the University of Applied Science in Munich. And we're going to talk about e-health and e-health standard, which is called Health Level 7 today. I don't know if you're still a bit tired from the weekend, because I saw that there is a habit here of warming up, so I'm going to warm you up on the next slide when we're going to talk about the overview. Okay, so this is the topics covered on this presentation, a short overview of world of e-health. We're going to talk about I'm going to show you a bit of the context of e-health, and then I'm going to talk about e-health standards, and then a bit of an e-health architecture, and then we're going to get into the subject of the HL7. Can you guess which part was my biggest challenge when doing this presentation?
Conclusion. Because that is the interesting part.
Yeah. This was part of my challenge, but I had the bigger one. Well, I had to reduce the number of slides to just 173.
You have only 1 hour.
Yeah. Hopefully I won't make
3 slides a minute.
So probably you are now warmed up. You can see it's only 100. That's it. Okay.
Please,
so this is an overview of e-health. There are so many definitions of what e-health is, but this one I think it seems appropriate. I mean, just in my mind it sounds really good. So e-health is a healthcare practice supported by electronic processes and communication. I'm not going to get into details, but just to know a bit of the moving parts of the e-health system. There is usually telemedicine and telecare, and you can either split it like this in telemedicine and telecare, or you can view it as a set of applications and services. The applications consists of the software that handles the electronic healthcare record and health cards and so on. And the services are provided through these applications to elderly people or disabled people or people who need assistance. So how do we ensure interoperability between all these components? You can see here that we have physicians, pharmacies, hospitals, insurers, governments, R&D, and so on. How do we ensure interoperability between all those moving parts? Well, the answer is rather simple. We use standards, e-health standards. This is a picture that you already seen last week, but it's important to have an overview of this one. And the most important parts of which I'm focusing on is the number of HL7s that you see here on this chart. This means that HL7 is used in hospital labs, in pharmacies, labs, and so on. We will talk a bit more on this on HL7, but this is a nice picture so you can have an overview of what HL7 is used for. So, what are e-health standards? Exactly like networking, e-health standards define sets of rules that define communication. So how do you transfer medical data from one place to another? What is their main objective is to ensure interoperability, which is syntactic and semantic interoperability. Now the question, can Gaspar develop e-health standards? Probably yes, but it has first to become an SDO, Standards Development Organization. I mentioned this one because maybe it's interesting for you to know where these standards came from, who invents them. So, how do you get to be an SDO, or Standard Development Organization? Well, you get accreditation from standardization bodies, such as ANSI, CEN, or others. So the way it works is that there are some organizations, huge organizations, that give accreditation to smaller organizations that can build standards afterwards. Example of e-health SDOs, among others, HL7, ANSI X12, and another one. We will focus on this presentation on this one, on HL7. What about the networking? E-health standards rely on different communication protocols and computer networks depending on their purpose. This slide is to show you that e-health standards don't necessarily define ways of communication. So the actual channel does not matter. The standard defines only the way data is structured and transferred from one place to another. This is why e-health standards such as HL7 are on top of communication channels or architectures that are based on body area networks, personal area networks, and other type of short, medium, and large distance communication. Can you imagine designing an architecture for such complex systems that includes both LAN, WAN, and other things? Can you imagine building an architecture this complex? Well, maybe you can imagine, because we've talked about it last week. This is an architecture, continuous reference architecture, that was built exactly for this purpose. I will talk a bit more about the Continua Health Alliance and how this architecture came up, and then I will refer to the architecture again. So the aim of this architecture is to design a complete end-to-end ecosystem for delivery of health information between patient and hospital information system. So this is the keywords to remember: end-to-end ecosystem. That means that from the patient until the hospital information system. The Continua Health Alliance that built this, that created this architecture, consists of hundreds of really big companies. I mean, any company, basically, any company that you can think of is part of this Continua Health Alliance. Nokia, Intel, Siemens, and so on. They all aim to build this architecture in the way that the patient, the data coming from the patient gets transferred somehow to this one does not work anymore. Do you have another one? The battery
Works. They have to be there.
Yeah, there you go. Thanks. Yeah. The basic idea is to make the architecture for transferring the data coming from personal devices, so from sensors directly applied to persons, patients, into healthcare records. So this is the basic idea. How they come up with this architecture? Well, they took millions of use cases considered by each of the member companies that is part of the alliance. And they built an architecture consisting of 5 classes of references and 4 network interfaces. And they recommended that these 2 standards are being used here. Where is it? This one, ISO-IE, and then HL7 here and here. That means that the recommendation of this Continua Health Alliance is that HL7 is used in order to transfer the data between the personal manager and the hospitals. That means that HL7 plays really an important role in this communication. By the way, just to have an idea of how important HL7 is, you can think of HL7 in e-health as in TCP in networking. So it's as important as TCP in networking. Okay, HL7 stands for Health Level 7. Do you have any idea why 7? not other number?
Lucky.
Not you. Sorry?
Lucky 7.
Lucky 7. Why 7 and not another number? One of you, please.
Because it's on the application level, and application level is an iOS model system layer.
Yeah, this is the reason. So 7 is because it's on application level from the HESUDI stack of protocols. So HL7 is an ANSI accredited SDO, so Standard Development Organization. These two slides are about HL7 as an SDO. I'm going to talk about this because there usually is a mixed, you can make confusion between the SDO and the actual standards. They bear the same name, unfortunately, but we will refer to it later. So we're now going to talk about HL7 as an SDO. It focuses solely on developing healthcare informatics interoperability standards. So these are the keywords, interoperability standards. Over 2,300 members and 500 corporate members. 90% of the worldwide healthcare information system vendors use HL7, either V2 or V3. This is a huge figure there, 90%. What does HL7 as an SDO do? They develop a wide range of e-health standards. The first one is, and the most important, is the messaging and data interchange standards, which are called HL7 V2, V3, we name it with X. They do a document standard, which is HL7 CDA, and then they do modeling and conceptual standards such as HL7 RIM. We were going to talk a bit about this one in a few slides afterwards. And then there's application standards such as CCOW, which handles single sign-on throughout medical applications. So these are examples of standards that the SDO defined. Now from this point onwards, we were going to refer to the HL7 as to the messaging standard. So not the organization that creates standards, but as a messaging standard. And we're going to start with the V2, which was really successful, and then we're going to get to V3, which is, let's say, at least as successful as V2. So, HL7 V2 is a messaging protocol. That means that it defines the messages that are sent between e-health applications. It's actually a family of standards grouped under the name V2.x because there were a lot of releases from 1 to 8. Does not specify the communication channels or the properties. This again is important because it's not restricted to a certain type of communication. You can use whatever channel you want to communicate data. This one is a nice figure. It's supported by 90% of the hospital information system in the US and the most used healthcare interoperability standard in the world. And there are some people that prove this. Most common notation for HL7 V2 messages are ASCII strings delimited by separators. So these are concepts defined by HL7 V2 that define how messages are sent from one place to another. They use segments, field, component, and delimiter characters. And if I go right to an example of HL7 V2, you can see that there are these are called separators, the vertical bar. These are called fields, and so on. So these sort of segments, fields, components, and delimiters are used in order to build a V2 message. And this is the logical separation of V2 key concepts. Once again, you have the whole message, you have the segments. We start with the segment identifier. I will give you an example. This one, message header, which is shortened MSH, is one segment. And then you have fields, such as for instance this one. This one is a field. And then you have delimiters, which I show you the vertical bar, and then data types and vocabulary. So this is how you structure V2 message. As you see, it's not really pretty. It's a bit difficult to understand if you're not used to the way it belongs. And you can see here that you have to count the number of empty fields, and you may get lost in counting all these numbers before you get to this one. So this is not the best representation, and we'll see that V3 changed the representation of the messages, and in my opinion it's a bit better now. What are the downsides of V2? Because I mentioned earlier that 90% of the vendors and the hospital information systems in the US still use V2. What are the downsides? The communication parameters, vocabulary, and coding terms are defined ad hoc, which means that it's it gives an interoperability issue. So that means that, for instance, with this message, when two applications define their communication and the messages that are sent from one to another, they should, prior to the communication start, they should define each of these fields, whether it is in a message or not. So they should establish a common set of rules from all the possible fields in the message, which ones are used and which ones are not used. As you can see here, there are a lot of optional fields that may be used or not. So this is a problem because, for instance, if two applications decide on a set of rules, that means a way of formatting information from one place to another, and then comes a third one which uses a different set of rules, then there's an interoperability issue because the three of them don't communicate immediately. And there's a lack of an information model, and we will see in V3 how helpful an information model is. There's a lack of formal definition of content and relationships between terms, and the degree of optionality and ambiguity is really high. It's not synchronized with newer technologies, which is again very important, and there's limited extensibility. So these are the downsides of V2, and these are basically the reasons why they've started developing V3. Actually, V3 started being developed in parallel with V2. It's been on since 1996, so it's not really a new standard. It defines a totally different development approach, and we'll talk about this shortly. It was designed to be forward compatible but not backward compatible. Do you know what this means? To be forward compatible but not backward compatible. Yes, please.
If you get information and you get a new type, you can use the old information, but if you get the information from an old client, you can't use it anymore.
Yeah, the basic definition would be that if a V4 would appear, then V4 would be compatible with V3. That means that V3 was designed so that next releases of the standard will have to maintain compatibility with this one. On the other hand, not being backward compatible means that V2 and V3 are not compatible. That means that they cannot be used in the same time, which is really a huge problem in the e-health world. HL7 V3 is an actual family of standards itself. It contains a lot of standards. We will not discuss all of them, of course. Even though it corrects much of V2 issues, it is not yet used as a mainstream standard. And my question to you is, why do you think that happens? Why is it not yet used as a mainstream standard, even though it corrects much of the V2 problems, and They pretend to have better interoperability, better information model, and so on. Why is it not? Yes, please.
Maybe because of the costs, you say they are not compatible.
Exactly because of the costs. So V3, excellent answer. V3 is not compatible with V2. 90% of the healthcare use V2. How do you get from V2 with V3 without a boost of cost? You cannot. So this is the reason why V3 is actually a bit better than V2, but it's not that used because it's difficult to ensure interoperability with V2. Now, why is V3 supposed to be better than V2? Well, there are a lot of arguments here. And the first one is that it supports all healthcare workflows through modeling. And this is a huge factor, the modeling factor. It reduces the optionality, maximizes reuse, and increases consistency. I showed you in the V2 message, there are a lot of vertical bars and nothing in between. Those are optional fields. If you have many optional fields, then you have to agree with the people that you communicate with. You have to agree which ones are used and which ones are not. The way V3 works is it reduces this sort of optionality in order to increase consistency and the way applications see messages. Why is it better than V2 again? Is because it introduces a reference information model. We will talk about this shortly, but basically this reference information model is used for defining every message in the healthcare world. So we can define anything that moves throughout the healthcare world with this information model. And then you have the development framework, which is used for documentation, static models, dynamic models. All of these are standards. And then you have the model interchange format, which is the HL7 meta model. It's used for defining all V3 artifacts. And then there's implementation-specific technologies, which are format-independent messages instance. Mostly use this one. We will see again this in a few slides. So this is where it all starts. It starts with the RIM, so reference information model. So think about just information model. So this is the information model, and this is the backbone of HL7 V3. As I put it in this slide, and I wrongly put it in this slide, as simple as this. It's a set of 6 classes. Everything that is sent, every message, every entity, every item described in eHealth can be derived from these 6 classes. As simple as this. Well, if you have, so the way it works is you have these classes, and then you do some sort of operations. Refinement, constrainment, and localization. The refinement means the restraint of the model to a specific domain. This is achieved by selecting only the classes and attributes specific to that domain. That means that from this one, you will use refinement in order to set up the classes that you need in a specific domain. For instance, laboratory or radiology, things like this. This is how we use refinement. Constrainment, on the other hand, is used to restrict attributes to specific vocabulary. So V3 is closely linked to vocabularies. Vocabularies contain definitions of terms used in every language throughout the world. And localization is the adaptation of the model to the particularities of eHealth system in a specific geographical area. So it refers to the localization, to the geographical localization. 2 slides after I put this text here as simple as this, I came back to this one. I was forced to cut the simple part and put it the right way, as complicated as it is. So this is the first picture was the real backbone, was the 6 classes used in every for deriving the whole every item in eHealth. And this is the extended ring. It's not that that easy to read, but the good news is that this is just the beginning. And what you've seen here, these many classes, these belong to this level. And from this level on, you have an ugly process of defining and refining and constraining models. But I will try to make it as clear as possible so that you understand how HL7 works. So you work on from the top down, even though this picture is other ways around. So you go from this picture on, you make some refinements and you get this ugly picture, and then you use this picture with the general classes as the rim stable model, and you use those refinements in order to define messages. And the process of defining messages is as follows. The first thing you do is you define the domain information model, or the domain model, which means that you take the classes from this reference model and you assign it to one specific domain. For instance, pharmacy, clinical documents, radiology, whatever you like. So the first thing you do is define a domain in the eHealth world. The next thing you do is you constrain this model into a RMIM, which is a reference model. That means that every message here will be a message that is sent in the in between eHealth applications. That means that after you define the domain, for instance pharmacy or radiology, you define every messages that can be or will be used in this field. And then you will get to a serializable model, so the models that can be sent throughout a network. And then you choose an ITS, which is a serialization format. And usually this is XML. So let me present all this in a few words. The domain message information model is a model derived directly from the HL7 ring. It represents all the concepts needed to support the communication required in a particular eHealth domain. The is comprised of clones of ring classes and is not intended to be serialized. So once again, this is the meme. It defines the domain of the eHealth where you will use the messages. The next thing is RMIM, which is refined message information model. Is obtained from by constraining the domain. As opposed to the domain, it has a single entry point and can be serialized. So this one is here. A single entry point means that one person is responsible for sending the message. For instance, if you build a scenario starts from one point. There is one trigger or one person that starts the communication. There is usually one point that starts the scenario. This means the single entry. And the last one, the implementable technology specification, describes a method for encoding HL7 artifacts. It specifies how abstract models can be serialized and transmitted. Most commonly is XML. So once again, I'm sorry, but I have to insist on this picture. You get the ring backbone, then you refine it in order to obtain the domains, and then you constrain those domains in order to obtain all the messages that work under this domain, and then you serialize the messages into a specific format. Once again, XML is being used more often, but it's not the only one. Okay, as you can see, the the way it works is that you have to refine and constrain and all over. Who does this? How do you constrain, or who defines the domains? Who defines all the messages within the domain? Well, it's usually done by organizations such as EHE. I don't know if you heard about it. Maybe you do. EHE builds integration profiles. Integration profiles starts from the fact that V3 is too generic. So we have those 6 classes from the ring background that define the generic context defining all the messages. This is too generic and has to be refined to models, to messages in the models, and so on. This is why profiles are defined for specific healthcare domains. Refinement, the profiles consist of refinement and constrainment of the ring to specific domains such as labs, patient care coordination, patient care device, things like this. The most prevalent organization that does this is EHE. This is an example of V3 message. So I've shown you once the V2 message, now is the V3 message. This is how it looks like, and as you can see it's in XML ITS, so this is an XML format. And this is an example of one message from a query of existing data, which is an integration problem. So this is much easier to read. For instance, you can see here query by parameter that you must ask always nice things about Gashper, not the way around. Now, back to this Continua Health Alliance architecture. We saw then HL7 is used here and here. The reason why it is not recommended here between the sensor directly and the smartphone or computer is that HL7 is not a lightweight protocol. So it's the way it was built, it needs computation, it needs messages are large, so you cannot send just plain data with a short header and that's it. So this is why Continua Health Alliance recommends that in the left hand side you have the ISO IEEE protocol, the one that we've presented last week, and then you have the HL7 that does that completes the chain from the aggregation manager to either the telehealth service center or the health record infrastructure. Conclusions. I'm pretty sure that by now you know all about BAN, PAN, TAN, LAN, WAN, and every other XAN. You do, right? Okay. And then, sorry? I skipped on them. Okay. I will. I will do it again. Okay, and you probably know everything about telehealth, telemedicine, telecare, and then a few more, which are these. You probably all know them by now, and I'm glad that I could make it all clear now. So, okay, if you have questions, I'm here to answer them.